name is Daniel Kwan and this is KTH Math Tutoring Club. Today we're going to talk about 2016 free response question number 4. In the problem, consider the differential equation and this formula dy over dx is equal to x squared minus 1/2 y. And the problem asks in the part A, find d squared y over dx squared in terms of x and y. So thus, we have to differentiate this to get the answer of second derivative. How should we do that? For some reason, many students will think, let's move this to left side, the y to left side, and x to the right side to separate each variables. However, as you can see, if we move 1/2 y to the left side, it is not multiplication, but it is addition or subtraction. That means we cannot do anything with dx because, so I'll write it down. If we did 1/2 y by moving it to the left side, now what you're trying to do is moving dx to the left side, but you cannot do that because it doesn't have the same denominator. So this won't work. So what should we do? dy dx is given, and it asks us to find the second derivative. So just differentiate. What is differentiation of 2x? X squared, I mean? I spoiled it. 2x minus 1/2 natural number. However, because this is y, dy dx. Thus, dy dx, don't get scared because this is this equation. So you just need to plug in. And this will be our final answer, which is x, simplifying, minus 1/2 x squared plus 1/4 y. To make it a little clearer, this will be our final final answer. And this was part A. Part B. Part B says, let y equal to f of x be the particular solution to given differential equation whose graph passes through the point -2 and 8. And the problem asks, does the graph of f have a relative minimum, a relative maximum, or neither at the point -2 and 8? Justify your answer. So justify our answer, right? So before anything, let's review. If you want to check, you can check the previous videos. But let's review the relationship between f prime, and f double prime. So I'll quickly review. When f is 0, let's go with column 0, positive, and negative. So when f is 0, the root of f, where the function itself crosses the x-axis. So in other words, when f is 0, obviously the line or the graph will cross 0. I'll go a little faster. When f is positive, the function is always above the x-axis. That's obvious, right? And vice versa, if f is negative, the function is always below the x-axis. So we're done with that. If f prime is 0, remember, it is a critical number. And it is possible to have either maximum or minimum. And to convert this, you can check other videos again. You have to use first derivative test or second derivative test. If f prime is now positive, the graph of f is increasing because this shows the slope of this function f. So if f prime is positive, then the slope is positive, which means it is increasing. And vice versa again. If f prime is negative, then what? Slope is negative. That means the function is decreasing. Now, lastly, so we're done with that. F double prime. F double prime, when the function is 0, we know it is point of inflection where the concavity changes. And before that, f double prime shows the concave up or concave down of the function f. And the f double prime, when the f double prime is again 0, it will be point of inflection, POI. If f double prime is positive, then the function f is concave up. And if f double prime is negative, the function will be concave down. And just in case, I trust you guys, but this is concave up. You can just think up, right? And this is concave down. You can just also think how arrow points up and arrow points down. So concave up, concave down, okay? And if, when we plug in any numbers for f double prime and becomes negative, which is less than 0, that will be our relative max. Because, like I said, if f is negative, that means it is concave down, which becomes maximum. Concave down, maximum. Vice versa, if f double prime is positive, because it's concave up, then it will be minimum. So let's jump. And sorry, one more. This will be f double prime and this will be f prime. Like I said, step by step, f to f prime to f double prime. However, because in this question or this problem, the single f function is not given, but starting with f prime, which is dy dx, let's start with f prime. And don't get confused because it says let y, dy dx y, be f of x. So, the problem asks us if we have to find relative min or relative max or neither. For it to have neither, it must have a natural number or any numbers. However, if this equals to 0, that means it will be either relative max or relative min. Let's try. Negative 2. So it is 0. So like I said, if dy dx is 0, then what? Let's go. Now, the condition that dy dx is equal to 0 gave us a next opportunity to jump up to d squared y over dx squared, which will be. Now, let's do the math. So, like I said a few minutes ago, if d squared y dx squared is negative, what is it? If it is negative, it is concave down. Point maximum. Thus, only justification you have to show is that the graph f has a relative max because the slope, the concavity is negative at point negative 2 and 8. By showing this works, this will get you a full point. So do not worry about that. So this was the answer for part B, and let's jump right into part C. Part C says let y equals to g of x. Because it is given that y is equal to g of x. Be a particular solution to the given equation with, now the single g is given, negative 1 equals to 2. Find limit as x approaches to negative 1, g of x minus 2 over 3 parentheses x plus 1 squared. Show your work that leads to your answer. So, if you have solved enough problems, you will see. Yeah, L'Hopital, right? Because limits and College Board will never give you that kind answer. So, as you can see, 2 minus 2, 0, negative 1, 0, right? Because negative 1 plus 1 is 0, and this is multiplication. So what we gotta do is the L'Hopital's rules. But before that, for your answer, you have to write. So if we differentiate this, it'll be, like we said, g prime. Oh, before that, to not waste your time, because part C gives y is equal to g of x, you don't have to substitute this in. You can just say g of x and g prime x. Over. So let's plug in the given points. Raise it. Yeah, negative 2. At g negative 1, it'll be 2. Let's plug into this equation, dy dx, because that is g prime x. So if we do that, now let's do the second derivative. Limit x approaches to negative 1. I did this quickly. You can just say, simplify this out, FOIL it out. 6x plus 6, FOIL it out. And then differentiating, natural number goes out and x goes out, so 6. So now we can see, because denominator is 6, it can never be 0 over 0. So here. Limit x approaches 1, g double x over 6 is equal to, the 6 is given, we don't have to do anything about it, and because we solved it, this is negative 2. So that is that will be our answer, and because the question only asks us to solve for the limits, we just have to get the final answer. So this is not done yet, like that. Never forget to simplify, you will get like -1 or something. So that is it for part D. Part D. Part D says, let y equal to h of x be particular solution to the given differential equation with h equals to h0 equals to 2. Use Euler's method starting at x equals to 0, the starting point, with a two-step of equal size, so two-step size, to approximate what is h1. So, before anything, let's start with what is Euler's method. As you can remember, so this is the Euler's method, and based on this, we have to solve the problem, yes. And before that, let's not get confused, because in the problem, it says, in the beginning, let y equals to, so this y equals to h of x. So that means this will become h of x. So I'll write small h of x and like that. So for you to not get confused, h and h, so we will put this step size as, let's say, yeah, t. Let's go t. And let's start. So, because we start at 0, the starting point, and then an answer that is h1, so 0 and 1, and it says the step size is 2, so that means I will reward it. We need 2 steps to get into here. So 1 minus 0 divided by 2 is 1/2. So step size, the h or the t in this case will be 1/2. So t will be 1/2. H of x, so we want h of 1/2 equals to y minus 1, which is 2. So 2 plus h, the step size, 1/2, so which is t, 1/2 times. So you're questioning, what is this? This is prime, which is dy dx. This is same thing as h prime x x minus 1, there we go. However, because in the problem the y it is given that y is equal to h of x, this will be this. So when we plug 0, because right now we want 1/2, but it's n minus 1, so 0. When we plug 0 into here, the first differential, which is prime, it will be 0, first of all, yes, 0 minus 1/2, don't put 0 there, y value is 2, so small 2, like that, equals to 3 over 2. So the first step size is 3 over 2, the first step. When the x value of h is 1/2, then h value is 3 over 2. So let's put it here. Now it's just literally a repeating step. So thus, h of what do we need? Now jumping into 1, right? Because 1/2 plus 1/2 is 1. Equals to h minus 1. Oh, one thing I didn't mention was this. You can review the Euler's method in the other videos that I have, but n minus 1 doesn't mean that you literally subtract 1, but this is n minus 1 step size. Thus, because this is 1 step size, thus 1 step size is 1/2, that means n minus 1 will be minus 1/2 technically, mathematically. Thus, do not take this literally, but mathematically, according to the case. So 1/2 equals to n minus 1, which is minus 1/2. So, which is this, right? 3 over 2 plus, I almost got confused, step size. Step size, h goes to t, so 1/2 times. Now, we're plugging in this to here. So, box it. So x value, 1/2, 1/2 times 1/2, 1/4, right? Minus 1/2 times 3/2. There we go. College Board is so kind, they made it the same denominator. So on the both sides, and will be 5/4. So the final answer will be 5/4.